Hi, Algebra 2 students. This video is on using the law of sines to solve triangles. So this video is going to correspond with the back side of the worksheet from class, so the side that says continued right here, and it has the law of sines as the three ratios. And specifically, I'm going to be going over problem number 1 under the exercises. This is a problem we started in class in period 1, but we did not get to finish. So I'm going to just kind of restart it and kind of recap what we had done in class, as well as show you how to finish solving and get both solutions. Okay, so in these problems, the first thing to do is to check the number of solutions. And the way we check the number of solutions, so we're going to check the number of solutions. And to do that, we're going to be referring to, on your worksheet, this box right here, which gives us, it says, suppose you're given A, B, and big A for a triangle, so that means 2 of the sides and 1 angle. If that angle is acute, that is where we are checking this condition, okay? So this is information I will not have you memorize, but I will give you on a test situation. So the idea is we would like to compare the A value to the value of B sine A, okay? And so in our case, little a is 34, and we'd like to compare that to 40 sine of 50 degrees. And we did this in class, and in the calc, we typed the 40 sine 50 into the calculator, and we got 30.6. So then the idea is we're comparing 34 to 30.6, and we would say 34 is greater than 30.6. So if A is greater than B sine A, if you refer back to that chart, that means that there are 2 solutions, okay? So this is the situation in which we should get 2 solutions. Okay, so now that that's taken care of, we're going to go about finding the first solution. And remember, a solution means finding all of the sides and all of the angles. So there's 6 values to find, and you'll be given 3 of them. You'll be given 2 of the sides and an angle, okay? So we just found out how many solutions we're going to be looking for, as in there are 2 possible triangles that have one angle of 50, the opposite side of 34, and another side of 40, okay? So the next thing we're going to do is we're going to use the law of sines to find B. And when I say B, I mean big B, which is angle B, okay? So the law of sines is telling us we can set up 2 of these proportions. I'm not going to use the sine C over C one right now because I only have A's and B's. So I'm going to do sine of 50, that's sine of A, over little a, 34, is equal to sine, I don't know angle B, so that's my variable, over 40. And the idea is we need to solve to find the missing part. So in this case, we're missing B, so we're going to first solve to get sine of B by itself. So if I multiply both sides here by 40, it's going to cancel it out there. I'm going to be left with 40 sine of 50 divided by 34 is equal to sine of B. And we did that part in class 2, and we got that sine of B is approximately 0.9. The next thing we did in class was we did inverse sine of 0.9. We did sine inverse of 0.9 to find that B is, we got 60, what did we get? 64.2. So now I know that B is, that is big B, sorry. Big B is 64.2. So now I have big A, big B, little b. I don't have anything about C yet. One thing I want to quickly point out here is that we just got a sine value of 0.9, and then we use the calculator to spit out what the angle is that has a sine value of 0.9. But the reason there end up being two solutions in this situation is because there's one triangle where angle B is 64.2, and notice this is an acute angle, and that's important. But that's not the only angle that has a sine value of 0.9, because if you think about the unit circle, positive 0.9, just really quick, if you sketch a little unit circle, 64 degrees is about there, right? So that point has that y value of 0.9. But there's also a point over here that has a y value of 0.9. So that we need, in order to find that second B value would give us the second solution set. So we're going to come back to that later, but first let's finish solving for the case in which the angle is 64.2, but eventually we're also going to need to think about the obtuse angle B that has a sine value of 0.9. Okay, so now what we're going to do is we found angle B, so now we have angle B and angle A, so it's not too hard to find angle C. So we're going to find angle C by subtracting A and B from 180, because we know that all of the angles in a triangle should add up to 180. So if we have two of the angles as 50 and 64.2, we can get the third one by just figuring out what's that last number need to be so that they all three add up to 180. And when we do that, we get 65.8. Okay, so what does that mean? That means that our angle C is 65.8. Okay, so the last thing to do to finish solving this first triangle would be to find side C, little c, because we already have big A, little a, big B, little b. We found big C, now we need to find little c. So we're going to find side C using law of cosines again. Sorry, law of sines. I said cosine. So now the idea is I need to set up a ratio that has C in it. So if you kind of refer back, we definitely need to use sine C over C, and then doesn't matter which of these two you use. You could use either one. And I'm just going to, for the sake of simplicity, I'm going to stick with the A values because those are whole numbers. So setting that up, we would have sine of 50 over 34 is equal to sine of C, which is 65.8, divided by little c, which is our unknown right now. Now, to get this little c by itself, you could think about kind of multiplying both sides of this equation by c, and then you're going to have to multiply and divide by something. You could also always, when you see a ratio, cross multiply, and in this case, cross multiplying is going to kind of get us to where we need to go faster. So if I do c times sine of 50, that's one of the cross multiplying, I get c sine 50 is equal to 34 times sine of 65.8. And then if I want this c value by itself, I would divide by sine of 50 to both sides. That cancels it out on the left. Excuse me. Okay, so that cancels it out on the left, so we're left with c, and we're going to get an approximation here. So at this point, you need a calculator. So if you put 34 sine 65.8, get an answer, and divide that by sine of 50. You could also put this all into the calculator all at once without extra parentheses, because it's all multiplication and division. And then it should spit out a c value. And the c value we get here is 40.48. Okay? So now that would be our kind of little c, right? So now we started with 3 of the values and we found the other 3. So we have solution 1, I'm going to call it. And this is going to be with the acute angle B. This is where we chose the acute B value there. So we started with a little a, And we started with those being 50, 34. Then big B is, we found to be 64.2. That's a 6. And little b we found to be, or we started knowing it was 40. And then we just found big C is 65.8 and little c is 40.48. Right, so we kind of end with, this is one whole solution, which is one triangle that fits those requirements, okay? But we now need to find the other solution. Okay, so to find the second solution, the idea of this is you will always figure out that other b value. You'll have to figure out that other b value. And the way we do it is you take the first b value you get, 64.2, and you subtract it from 180. Because if you think visually, 64.2 is the distance from, say, 0 up, right, to this point right here on the unit circle. Well, if I want to know the point over here that's like the reflection of this point, it's that same number of degrees up from 180. So we'd want to know 180 minus 64.2 in order to figure out what the angle is right here, okay? So what we're going to do, we're going to subtract our acute B, that's angle B, from 180 degrees to get the obtuse angle B, which is going to lead us to a whole nother solution. So in this case, that means we're doing 180 minus 64.2, because that was the B value we got originally. And I'm going to take that, and that gives me 115.8. So this right here this is now the new B value for the second solution, and it's obtuse. Okay? So now that I have my new B value, I can find the other angle C. So now, find angle C the same way we did before. How do we find the third angle? We subtract from the two angles we know from 180 degrees. So we're doing the same calculation here, except instead of using, I'm still using 50 degrees for A, but instead of using 64.2 for B, I'm now using 115.8 as my B value. So this was angle A, angle B, and I'm going to get angle C. And when I do that subtraction, you end up getting 14.2. As the angle measure of C, okay? So now we have angle B, we have angle C, we have angle A. We started from the beginning with little a and little b, so the very last thing we need to find is little c. And the way we're going to do it is the same way we did before, by using the law of sines. So the setup is going to look similar to the ones we were doing before. Sine of A, 50 degrees, divided by the length of side A, which is 34. And I'm setting that equal to, I'm going to just use my other color pen so we can see this better. So sine 50 divided by 34 is equal to sine of sine of C, so that's sine of 14.2 divided by little c. That's the unknown. So again, I'm going to solve this by cross multiplying. So when I cross multiply, I get c sine 50 is equal to 34 sine 14.2. And at that point, I would divide both sides by sine of 50. And I have to punch this into the calculator to get a value for c. But if I put this whole thing in the calculator, I'm going to get an approximate value of C as 10.89, okay? So then putting it all together, we get like our second solution set. So solution 2, this is where we have the obtuse B. Would be A, little a and big A stay the same. Big A is still 50, little a is still 34. Big B has changed. Big B is now 115.8. And little b is now, little b is the same as it was before, 40. And then C, big C is 14.2. And little c is 10.89. So we see we get 2, when it says 2 solutions, there's actually a lot of values that go into those 2 different solutions. So again, your homework tonight is to finish the worksheet from class. So what that means is on this worksheet, you're going to try 2 and 3, and you can do those by following the steps I just modeled here. And on the other side, you're completing 3 through 11. And you're using the area formulas at the top. So we will be practicing both of these processes in class next time I see you.